Okay, so we're going to talk about imaginary numbers and what it means to have an unreal solution or a non-real solution. So this happens when you have a parabola that does not have x-intercepts. Say we have a parabola that looks like this. We would say it has no real solutions because it doesn't cross this x-axis. There are no x-intercepts. And because of that, there are no real solutions. But interestingly enough, a famous mathematician decided to come up with the idea of imaginary numbers, in which he called the imaginary number I is equal to the square root of -1. So therefore, I squared would be equal to whatever square root of -1 squared is, which would just be -1. This is the main idea of imaginary numbers. So I'm going to show you guys how to solve a few equations and how to break down these square roots. Because as we've learned up until this point, having a negative inside of a square root is bad. We can't do that with real numbers, but we can with imaginary numbers. So what we're going to do is we're going to take a problem from our classwork packet, from problem 129. Let's do 129A. 129A says we have 2 times 3 plus I. So what we're going to do is we're going to distribute. So 2 times 3 and 2 times I. So that would end us up with 6 plus 2I. Now, what's one other thing that's important to note is that we cannot combine these two. These are not like terms. Whenever we have I attached to another number, it can only be multiplied by other numbers. We can't just add it to any other number. The same way how we used to have something like 2x plus 8, let's say, we can't combine these like we could with regular numbers. We have to leave them separate because they're not like terms. So that was just an extra example. So this is as far as we can go. This would be our answer. So let's talk about 129b next. So 129b, we have 10 minus 9i minus I. So here we have 10. Are there any other constants? Any other regular old numbers? No. So we're going to end up with 10 still. Can't combine that with anything. And then we have -9i minus I. These are like terms. We can combine these. So that would be minus -9 minus 1 is -10i. And then from here, we can't combine it any further. So this is our answer, 10 minus 10i. Let's do another one, 129c. So here we have, let me draw it a little lower, -2 minus 7i plus -1 plus 4i. So here we're simply just adding. And we're going to add everything together that we can. So -2 plus -1, that's the same as subtracting. So it's going to be -2 minus 1, which is -3. Then we have -7i plus +4i. So -7i plus 4i is -3i. This is as far as we can combine it. We can't go any further than this. So that is our answer. Let's do 129D. Here we have -8 plus 2i. -8 plus 2i minus 1 minus 6i. So here, what we do is now we're subtracting by this whole term here. So what we need to do is we need to distribute this negative. It's very important that we remember that. Let's go and get started. We have -8 minus 1. So -8 minus 1 is -9. And then we have 2i minus -6i. So since it's minus -6i, what's happening is we're actually going to add the 2i. Or sorry, the 6i. So it's going to be 2i plus 6i, which would be 8i. So there we go. That's as far as we can take it. So that would be our answer. And finally, we have a little bit of a tricky one, 129E. Now, what 129E says is it says 1 minus I times 8 minus 6I. These ones are multiplying, which if you know FOIL, great, you can FOIL it here. If you're a little bit less familiar with FOIL, that's okay. We can use the box method like we've been doing before. So we have 1 minus I and 8 minus 6I. So we end up with 8 times 1 is 8. 8 times negative I is negative 8I. And then we have negative 6I times 1 is negative 6I. And then negative 6I, be careful here, negative 6I times negative I, that would be positive 6I squared. Now we add all of these together. So we have 8 minus 8I minus 6I plus 6I squared. Just like that. Combine what we can. So 8 is the only constant. That gets pulled down. I, we can combine these two i's. So negative 8 minus 6 is negative 14I. And then plus 6I squared. Now, one thing to note from before is that I squared is negative 1. So we can plug in negative 1 there. So we get 8 minus 14I plus 6 times negative 1, or as we would more traditionally know it, 8 minus 14I, and then this would be minus 6. Now we can combine 8 and 6, so 8 minus 6 is 2, and then minus 14I. That's our answer. So one more thing I want to note before we move on is I want to go back to 5/126. So let's see, let me find a little bit of room. Here we go. So on problem 126, let's see, A, we have the square root of negative 4, and it's asking us to simplify this. So what we need to do is we need to break down this square root. So common way to do this is with a factor tree. So 4 is broken down into 2 and 2. And those are both prime numbers, so I'll take those. It would be negative 1 times 2 times 2. Now, because we have a pair of 2 times 2, right, the square root of 2 times 2 is 2. So that would leave us with 2 square root negative 1. Now, if we remember what I is equal to, I is the same as square root of negative 1. So we can rewrite this square root of negative 1 as 2 times I, 2I. That would be our answer. Let's do one more. Let's see, let's do a few more. Let's do B. So for part B, we have 2I times 3I. So here we're just multiplying these two terms together. So 2 times 3 is 6, and then I times I is I squared. So we end up with 6I squared, which if you remember, I squared is the same as negative 1. So that would be 6 times negative 1. 6 times negative 1 is negative 6. That's my answer. All there is to it. Not that bad. For part C, we have negative 5 times 2I squared. Now keep in mind the 2I squared, the squared goes to both the 2 and the I. So we need to kind of distribute that. So that'd be negative 5 times 2 squared, which is 4, times I squared. Which if we remember, I squared is the same as negative 1. So that'd be negative 5 times 4 times negative 1. Which 4 times negative 1 would be negative 4. Negative 5 times negative 4 is positive 20. That's it for that one. And then finally, part D, this will be the last one, I promise. Part D, we have the square root of negative 25. We're going to break this one down. So break it down as far as you can go. Factors of 25, 5, and 5. Those are prime numbers. So we end up with square root of negative 1 times 5 times 5. Because we have a pair here, pair of 5s, we can bring them out to the front. So we have 5 square root negative 1. So if we remember, square root of negative 1 is I. So that would be 5I. And that's the answer. That's really all there is to it for complex numbers and imaginary numbers. Really not that bad once you actually get down to actually solving these equations, or simplifying these equations. So don't worry yourself too much about it. The concept is pretty complex, no pun intended, but the procedure, not terrible. So best of luck, and that's about it.